I have the pleasure of introducing Alec Cartright. I am architect for BT.
Okay, thank you. Afternoon, everyone. As I said, Alec Cartright from BT, so I look after everything that's to do with identity and access management. One of the things is CA single sign-on. Let's whiz over that one. So, quick beginning. This is really looking at some of the experience we've had in BT around our deployment of CA single sign-on and the finger pointing you get. When you can't log on, CA single sign-on is always the thing that's gone wrong. But actually, in reality, it hasn't. So this is looking at some of the experience we've had and how we have kept our sanity through all the finger pointing. So if the clicker goes on, there we are. So we'll have a look at where do we use CA single sign-on? What do we do to stay calm? We can always get better and do more things, and then a quick summary at the end. So BT itself, think AT&T, but in the UK. So we actually operate across 170 countries around the world, and there's some figures, 150,000 employees, 27 million plus online customers. And where do we use CA single sign-on? So it's used across 450 applications. Some of those are our customer-facing ones, so servicing the 27 million customers, and a big chunk are our employee ones. We have 50 plus federations with various partners that provide services both for our customers and our employees. And one of the key things as well is it includes some very critical applications to BT. So BT recently, or in the last couple of years, we've started broadcasting soccer games. So football games in the UK, competing against the current incumbent Sky. That application there is protected by CA single sign-on. And if the login fails at the beginning of the game, our name is not very good. We end up in some deep, serious trouble. So that's a really critical application to BT and BT's success going forwards. So it is, when anything goes wrong, so I can't log in, CA single sign-on is always the thing they point the finger at first. So no pressure. We have got some fairly serious availability requirements as well. So we look at achieving telco grade availability. So 99.995. We can't shut the system down. There is no time in a 24-hour period or a 7-day week where we can say we can turn off logging, because there is always some people logging. There are some sad people who pay their phone bill on Christmas Day. Get that. There are some times as well where it's very hot. So BT Sport games, if you've got a soccer game on, it gets really busy just before kickoff. So again, you get these really sudden spikes of requests coming into the service, and we must keep the service running. Transaction volumes, 30, 40 million transactions a day. On a sports day, it can get more. And we have seen peaks of over 7,000 transactions a second. So that's a mixture of logins and authorizations and federations as well. So how do we stay calm? So if I didn't, I'd be mad in weeks. But so things we've done to help ourselves stay sensible is we've architected the solution for availability. So we've sat down right at the beginning when we deployed it and looked at how do we make it as highly available as possible. We've got things that let us know the health of our infrastructure. So how well is it running? Is it starting to look a bit sick? Is there something suspicious going on somewhere? And also, we have a lot of processes around it that help us quickly identify where problems are. So it might not be CA single sign-on's got a problem, it could be the database behind it or the directory behind it. So we've got tools and things that we've built that help us identify where those problems are. So deploying for resilience, some of you may have already come across the concept. So we deploy in clusters of 3 policy servers. So we work nicely with 3 because it allows you to take one policy server out and still maintain some local resilience. So you take one policy server out, upgrade it, bring it back up, and you've still got 2 running whilst you're doing the upgrade, and then you work on to the next one. Or if one fails, you've still got 2 running. Okay, so we always work in clusters of 3 policy servers. We use the web agent load balancing, so set up in a normal web agent configuration, and that's set up to just use its own internal load balancing. So we don't use any load balancers between the agent and the web server. We just use what's provided by the CA single sign-on software. Okay. The next thing we do is we say, actually, one site's not good enough. We deploy across 5 sites. So we take a cluster of 3 on each site, and a web agent will be configured to go to a primary, usually the one that's closest to it in network terms, and then configured to fail over to the subsequent sites. There is a little gotcha though. We did fall foul of it in our first version of the configuration, in that it's very easy to say, all the web agents on site 1 fail over to site 2. And then everything on site 2 fails over to site 3. So if you're getting a rolling failure, you suddenly find that everything's falling over to the same cluster. So you have to think a bit about how you spread the failover of the agents across the 5 sites. So you don't end up, when one site fails, all the traffic moves on to the next one. So you don't end up with a rates condition that actually itself forces a failure. So you've got to be really careful there. So a bit of thought in how you do that. The minus is that you then have to deal with multiple host configurations. But that's probably a little price to pay. The next thing we did is, because we're servicing customers and employees, we actually split the infrastructure in 2. So we now have 5 sites, each with 2 clusters on. One cluster supports employees, the second cluster supports customers. So if one whole infrastructure fails, one whole block of them fails, we've still got the other one working. So we can still place orders, we can still deal with faults, we can still watch sport. So there's always something working, and they are physically separate. So they have their own policy stores as well as their own policy servers, and the agents don't fail over between the 2 infrastructures. Okay, so if one fails, the other one's always going. All our other stuff round the infrastructure, so all the other components, so we've got federation services, we've got our policy stores, all those things come in pairs, or at least pairs. They're always come as a twin, and we usually deploy pairs across sites. So everything's deployed multi-site, all configured active-active, and if one goes down, SiteMinder, CA single sign-on is very clever at usually flipping over to use the other one. With the federation gateways, again, we put load balancing in front so that one site can fail and we switch traffic to another site. So monitor and alert everything. So we do monitor practically everything on our SiteMinder infrastructure. Looking at anything, we create 2 levels of warning. So there's an alert, everything below the alert, life is good. Once you get the alert, that's, oh, someone needs to look at something. So it's not gone wrong yet, but it could go wrong. So it's an alert that says, okay, someone's got to investigate. And then you've got the red warning, everything's going to break, we've got to do something quick. So we've got these 2 levels, and we use those to hopefully proactively fix a fault before it actually becomes a real fault. Beware when setting up the thresholds, though, that you don't create a cry wolf situation. It's very easy to set a threshold, and if it happens all the time, your support people will start ignoring it. So they don't want to know. It's just a bit of noise that's going on in the background. It always happens. Nothing's going wrong, so it's all right. So don't create those situations. It's very easy to do it. We always look at, if we start getting alerts, we'll always do an investigation to work out what was going wrong. And then we will adjust the threshold we've set, or we'll do some fixing to say, actually, we do need to fix something. Monitoring, well, we look at the CPU. Oh, it's all the standard stuff, CPU, memory, disk usage, what processes are running or not running, as the case may be. So it's looking at how these are working. So sometimes policy servers develop memory leaks, and you find the memory starts creeping up, so you just restart the policy server on a regular basis. And it's getting into these sort of procedures that says, when the memory gets to this point, we just restart the policy server. And then it all clears itself down and starts again. The operating system as well, if you leave them running for a long time, actually they develop memory leaks. So you just restart those on a regular basis. Disk usage is the good one, especially when you start turning things like tracing on. You can use your disk pretty quick. So again, it's looking at monitoring that and picking up the warnings so that someone can do something before it becomes a major problem. On a policy server, we use the OneView monitor, primarily looking at the server queue length and the priority queue length. These are good indicators to suggest to us something's going wrong or something's about to go wrong. So we know what they look like on a normal day, and we also know what they look like when we're using watching a soccer game. So we sort of know what the behavior is and what's normal. So now we're looking at trying to identify what's abnormal, what's unusual behavior. Log files, there's loads of stuff in the log files, and they're just a list of the sort of things we look for in the log files as telltales to say something's not quite right, something we need to start working on and pushing it along, do an investigation, find out what's suspicious. Getting the right issues to the right people. So we have a test login page, which is run on infrastructure that is owned by the CA single sign-on support team. So it's run on a simple Apache server. And all it does is let you test the login. So we can tell an employee, go to this login page, type your credentials, and it pops up with a little message at the end that says, now you've successfully logged in. All that does is it tests that the SiteMinder policy server is working and the connection to the back-end directory is working. And in fact, when we implemented this first, we cut down the number of support calls coming through to CA single sign-on by 80%. So the number of times when people just phoned up and said, I can't log in, it must be CA single sign-on, by telling them, go to the login page first. So they call up the help desk says, go to this URL. They go to the URL, log in. Oh, that's okay. The problem is actually somewhere else. So we use this login page to walk the user through doing a basic login. If that works, actually, the problem's not CA single sign-on. It's an application web server that's down or something else that's not working properly. If the back-end directory was down, actually that login page comes back with a different error message as well. So again, even if something is wrong, we still know that we can work through and identify where the problem is. It gives us some clues as to where to look. Another thing that we've done, so this is a simple diagram, but it's actually know your infrastructure. So we have a big, it's an A1 sheet of paper with all our policy servers on it, all the web servers that the SiteMinder team, the CA single sign-on team own on it, So we've got some WebLogic servers on there as well. We've got the databases that make up the policy store. We've got the databases and directories that make up the user stores. All the switches, so we've got pictures of the switches on there. We've got the GSS switch, so the content switch for switching between sites. All that information's on that picture. So you've got machine names, IP addresses. You've got contact numbers for people on that big, huge piece of paper. So when anything goes wrong, we could quickly go to the paper and say, who do I call? There's a problem here. Who's the contact? What's the queue that I need to raise a ticket against? So we can very quickly find who are the right people and then target the case off to that for them to have a look at. It took quite a while to do the picture. It took us about a month to get it absolutely right because we've got so much there. We've got sort of 84 servers in production that we've got to manage. But once it's been done, it was invaluable. We were having to deal with queries, and we could very quickly find out, all right, we speak to Joe Blogs about this server. So it was really useful. Other teams have then followed this sort of technique that we've done. It is worth the effort of putting it together. So we can always do more. We've implemented continuous improvement as a methodology within BT. So anything where we have a slight issue or something suspect, we go through a continuous improvement process. So we go through a root cause analysis and an investigation of what that problem was. So we investigate, we look at what caused the disaster, and then once the disaster is cleared up, we then look and work out what really did cause that thing to blow up. So we do a root cause analysis, and we don't always look at the first thing. It may be something else that's caused the problem. And be aware that sometimes these investigations can take a long time. So there's one thing we were looking at where we had suspect response times at odd hours of the day, and actually it took us 6 months to find out what was the root cause. And it was because we're on a virtualized environment. There was an application on another VM on the same physical hardware that was suddenly causing a network spike because it was shoving loads of data onto the network, and then that caused a problem for our servers, our virtual machines on the same physical hardware. So it was something completely not connected with us, and it took us ages to work out through all the little bits to find out exactly what was causing a problem. But once we'd done that, our odd response times disappeared. So well worth doing the investigation, but they can take a bit of a while. Something else we've just started to do, we've just deployed the CA APM, so the Application Performance Monitoring, and that's deployed on our policy servers, looking at the stats out of the policy server. 2 weeks ago, APM started throwing up a load of messages for us. We had a quick look and said, that's a database problem. Phoned the DBAs up and said, you've got a problem in your database. The DBA said, no, we haven't. Gave them the details, said, oh, yeah, so we have. So APM actually gave us a warning before the DBAs even know they got a problem. So it was well worth putting APM in. We're actually expanding the amount, the places we've got APM installed at the moment. It's just on a couple of policy servers, but we're expanding that out across our infrastructure, and it's definitely been worth it. The other thing we're doing at the moment, we use a database as our policy store. That's a sort of single point of failure, though we do have a DR site. So we're now swapping, as we move to CA SSO 12.52, we're now going to move to using a directory as our policy store. So we get a bit more resilience. We can run it across multiple sites. And in summary, so what have we actually achieved? In 13 years of running CA single sign-on, I can say we have had 100% service availability. We have always been at a point where at least someone can log in and do something. We've never had a total failure. We might have had issues on, say, the customer side, so customers couldn't log in, or issues on the employee side, so employees couldn't log in. But we've always had at least one or the other can log in. So over 13 years, that's our proud achievement. We have started now proactively warning people when things are about to go wrong. So the example with APM there, where we've been able to tell the DBAs proactively before the thing actually became a problem, before anyone even noticed it. So in fact, with that example there, the users never even saw an issue. We fixed the problem before it became a problem. And a number of years ago, CA single sign-on didn't have the best reputation in the business because everyone always pointed the finger and said, it must be CA single sign-on. And even when sort of 2 months down the line and they'd done the root cause analysis and said, actually, no, it wasn't, it was such and such bit of kit failed, that message never got back up to senior managers. Fortunately, on a recent event, we were able to provide enough information for the support teams at the time, where actually a senior manager on the call said, actually, SiteMinder here was just an innocent bystander. You were affected by all the incidents around you. You did your best, but actually, no, it wasn't your fault. So the view of CA single sign-on has changed across our senior managers. They're seeing it as it's just something that works really well in the middle, but unfortunately sometimes it can be affected by stuff that around it that we have no control over. So, but that's been one of our big achievements, to actually get to that point where we're described as an innocent bystander. So the thing final word then is one of the things we've been able to do now. So BT have recently launched an identity as a service, and we've now been able to take all that experience we've got of running CA single sign-on and use that in our Azure Cloud Identity service. So now we've been able to say, look, we know how it all works, we know what the issues are, so we've now launched a service that's based on that. A couple of sessions there, I think because we've changed the timing for this one, that some of those have gone, but certainly there's a panel session later on today that's probably worth a look, looking at cloud services. And actually, yes, we've got loads of time. I've talked faster than I was expected to. Has anyone got any questions?
Yep, my question is, you said that you have a fairly high transaction rate, but yet you only need 3 policy servers to service that load. Is that taking the whole load?
So it's 3 policy servers in each site. So we actually have 15 policy servers. And in fact, for that particular application that generates all that load, we have another 6 servers deployed. But they take the whole load. So was it 6 servers, taking 7,000 transactions a second.
Also, if you don't mind, what platform do you run on?
So we're running on Solaris T2000 servers with Solaris 10 using global and non-global zones. So using the Solaris containers. Each policy server has 4 gig of RAM and 4 CPU allocated, or 4 CPU equivalent allocated to it.
Any other questions? Okay.
A stunned silence. No?
A quick question. This is more like, as you said, right? I mean, like you have 15 per. When we are looking at on a global enterprise level, we have that number increased for us like in a dramatic way. We have like 50 plus servers across like dev, test, and prod. So we are trying to, again, this might not be correlating to the presentation, but wanted to ask you, have you ever looked about reducing the fingerprint, like footprint of these number of servers, like moving in a more cost reductive fashion, you know?
Yeah. So we have reviewed the number of servers we've got deployed because it does take quite a bit of time to get an upgrade done with the number of servers we've got. Because that's just, what you saw there was just production. We've also got 4 pre-production environments, not as big. So we have looked at reducing it, but actually what we've said is the availability requirement means we still want to keep the number of servers at that level. So policy servers close to where the web agents are installed, but also multiple sites because we want to keep that level of failover working. So we don't want to reduce the number of sites, and we don't want to reduce the policy service in each site. So we have reviewed it and came back with the answer. We still stick with clusters of 3 across 5 sites, and then extra clusters to support any extra capacity we need. So, and one of the things I have actually been looking at here is where they're starting to talk about using containers for building and deploying policy servers. That looks like a really good direction for us because it does allow us to move into that more elastic capacity. So that's a new thing CA have been talking about on a couple of sessions here. I think it's in the DevOps bit. Yeah, that looks really promising, that.
Hi there. I think you probably answered half of my question on that. What about the installation and configuration process for policy server and web agent? Do you have any automated solution in place right now where you can just quickly deploy web agent, let's say our Apache server goes down, do you have any automated solution to spin out another one quickly?
So the process we have is sort of semi-automated. So for each environment, we will produce a goal build policy server that has all the configuration for that environment, plus all the binaries installed and all the various libraries and things installed on it. And then we use that as a template to clone other servers within that environment. It's more a manual process we just produce the goal build manually and then clone it manually. But what it does mean is every policy server does look the same. We haven't looked really at trying to automate that. I think there were some debates about how long it would take to get the automation working versus how much benefit we get by doing the automation. And we came back to the answer, it wasn't worth it. But again, the containerization that CA is starting to talk about now actually does make that possible, that sort of more automated deployment possible.
What about your policy server? Is it running on a database or a directory?
So at the moment, the policy store runs on a database. We're planning to move to CA directory as that's licensed with 12.5.2. And we'll deploy it across at least 3 sites. Multi-master replicate. So that should give us good availability on the policy store.
Okay, any other questions? All right, thank you, Alec.